No. It's explosives, right? That's one way to do it. And indeed, if you look at controlled demolition where explosives are used, so you cut columns below the roof line, the roof indeed falls at close to acceleration due to gravity, g, just as World Trade Center 7. How do you get the mass out of the way? Now, NIST does not answer. We basically pushed them to include this plot because we challenged them, David Chandler and I, and they did it to their credit, but then you'd say, well, they would have to explain it, right? Or explain the collapse of the buildings, but they didn't. They just put a little statement in there. They said that this result is consistent with the results, that's where I start quoting, consistent with the results of the global collapse analysis, that means their computer model, discussed in Chapter 12. That's it. It's a sham. I hope you understand that as a scientist, I'm offended by this type of covering things up. I mean, we challenged them. They admitted free fall for Building 7. Free fall for some 32 meters, over 100 feet. And then you're waiting for them to say, well, fires won't do this. But instead they just say, oh, it's consistent with our computer model, which we won't let you have, which you can't test. You can't see if it's consistent or not. You just have to trust us. You see? Like when we say the dust is safe, please just trust us. No harm will come. Please. You know, as a scientist, I just am appalled. So here's again, we contrast students, the scientific method with the political method. In the scientific method, we gather facts, and we then draw our conclusions from the facts, as on the left. In the political method, we start with a conclusion, and then we find what facts will support that conclusion, and we ignore all others, or we simply say, oh, it's consistent with our, our theory that fire can explain it, and Al-Qaeda is solely responsible. By the way, you know that no plane hit Building 7, don't you? Al-Qaeda did not even hit Building 7, and they ruled out, NIST ruled out, as they checked, that the debris from the falling towers did not cause a fatal incident at Building 7 either. So they're stuck with fire, which indeed was caused by the towers, they say. But gosh, the way it fell down is not consistent, no, with fire. This is free fall. Plus the fact that in Building 7, Professor Barnett et al. At Worcester Polytechnic Institute noted that the steel was severely eroded, high temperature corrosion and sulfidation, which again Richard Gage talked about that. Do office material fires do this to steel beams? The answer is no. I mean, please do the experiment. Show me wrong. I beg of you. Show me how you can get a steel beam to look like this. Swiss cheese in appearance, burning paper and desk and so on. Kerosene would be the jet fuel in the towers. There's also steel like this found in the rubble of the towers and studied by these scientists at WPI. Now, did NIST follow up on these data? It's in the FEMA report and was published also in a peer-reviewed journal. The answer is no. NIST did not even look at any steel from World Trade Center 7. Not even these pieces that were collected. Again, they ignored the data. They asked us to trust their computer model, that somehow the free fall for over 2 seconds is innocuous, if I can use the term. Don't worry about it. Well, excuse me. There's something very strange going on. I am not just going to believe you that this is okay. It's just appalling. But hopefully they will someday say, well, like they admitted, we can't explain the total collapse of the towers. Well, perhaps they'll admit that with regard to Building 7 as well. But to ignore published data is again an offense in science. Okay, students, you're better than that. Let's see, I might say that this effect of holes in steel I was able to achieve quite easily using thermate, which is sulfur added to ordinary thermite. Thermite you can buy on eBay. Sulfur is not hard to come by. You mix them together and you ignite it. I use a sparkler to ignite this typically. And you see the effect is, and I've looked at this with scanning electron microscope as well, you see the sulfur penetrating the steel very quickly. And it forms a eutectic and it melts its way through. This is not even super thermite, which we'll talk about later. Just ordinary thermite with sulfur added. The steel is cut through, melted, and it has this Swiss cheese appearance. We're able to duplicate that. The WPI scientists also found sulfur in the steel in these samples. Where does it come from? You see, well, we have an experiment that can replicate. That's not a proof yet. To prove it, we would need to get a sample of this steel. We requested, as my colleague at BYU, Dr. Ferrer, talked to Professor Barnett at WPI and requested a sample of the steel, a scientific courtesy. He was refused. They will not. Now somebody must have power to get these guys to let us look at their computer model, right? And we'll plug in the actual heat transport value for steel and realistic values for fire and so on. And also to get a sample of this steel. That's what we want. We're looking for data. We're not just trying to, I don't know, be contentious. We want the facts. We have a right, I think, to ask these questions. In the past, asking questions has been commended, not condemned. Now about the towers. We'll go through this kind of quickly. Richard Gage has a great article on that. I want to show you, you see here in the upper right, you have a stove burning wood. I have a wood burning stove. And sometimes I'll put paper in there. So it's much like an office fire, I suppose. Office materials, typical in office, wood, paper. You could even put kerosene in there. I have a kerosene burning stove. It's also made out of iron or steel. You know, I don't expect that stove to deform and melt or collapse. It's just not going to do it. I've done the experiment many times. My kerosene stove also is quite happy to burn kerosene. You know, jet fuel would be fine. It's a type of kerosene. I don't see a problem. Furthermore, you look at the connections on these columns. They're connected together. Well, you can see it in the picture on the right. That means that if you have a bonfire under one, go ahead, pile up all the desks and chairs and paper under one of those columns. And you start that fire off, and it lasts maybe a half hour, something. But that heat is wicked away. Again, it's this heat transport, you see. And so you have to take that into account. Except in a computer model, of course. You can get away with murder, actually, if you think about it. But okay, back to the official model, now presented by Besant in a published paper. How to get a complete tower collapse. Their argument in this paper is that where the planes went in and there are fires, then somehow there's this weakness, rather simultaneous, and this upper block of floors acts as a tamper to push down, so it stays fairly intact as a tamper. Makes some sense, right? But wait a minute, how about Newton's third law, which says that if the upper block exerts a force on the lower block of floors, the lower block exerts an equal force, students, on the upper block. Equal. That arrow is not shown. It's not considered in this paper. It's there. You cannot overcome the laws of physics. Now, this is, again, a freshman error in physics, Newtonian physics, which I taught for over 21 years, to ignore the third law reaction force. But let's look at the data. Maybe somehow this upper block, as it moves, I don't know, exerts. Let's see what happens to the upper block from the data. This from the North Tower. And on the right, you see in slow motion the upper block. Is it just wiping out the lower block? You can see the area where they meet. No, the upper block itself is being disintegrated. Did you see that? Let's look at it again, please. You can see the antenna poking up there. The antenna went through the whole ride of this thing. So, but you see, there's a force equal and opposite, up and down, and the upper block, which by the way has thinner columns, that's the way it was built. The columns get, the core columns get smaller, thinner as you go up. Furthermore, the fire would have weakened the upper columns, and indeed that's what you see. It's the upper columns that are destroyed. So then what is left, where's this block, this tamper that's supposed to wipe out the lower floors? Sorry, it ain't there, you know. I mean, look at the data. you know, it just bothers me that they have this nice model on the left, but it's inconsistent with observation. It's also inconsistent with Newton's laws. Here's another photo showing later as one of the towers has collapsed. You can see the zone of destruction. It's quite clear, isn't it? You can see where right through here. But where's the tamper? Where's this block of floors? Well, indeed, there's smoke coming up there. It's gone. On both towers, you see this effect. That upper block of floors is gone by the time you get halfway down of the buildings, approximately. It's gone. There is no tamper. And it doesn't wait till you get to the ground for the upper block to be destroyed. It's already destroyed. It isn't there. It's just amazing to me that they missed that. So the official story is full of holes, just like the steel found. You see, it's just full of holes. By the way, the towers also came down at near free fall speeds. No stacked up floors. Here's an actual photograph then, following the collapse. Where are the stacked up floors? If there's some pancaking going on, like the Popular Mechanics article said, they're not there. On the right, we have pancaking that can occur, but it didn't occur at the World Trade Center. There is no stacking of floors. Furthermore, the core columns are gone. Those core columns provided a lot of the support in these towers, and they are gone. That suggests again to me use of explosives. Now, let's see. As I started writing about this, and here's one of these papers that I asked you to read as homework, I received an email from a fellow who identified himself as a contractor with Homeland Security contacts. As soon as this article was out on the internet, he wrote to me. I'm going to quote from his email. "The publication of this article can be stopped, and I have the contacts to make this happen. You need to give this very serious consideration. This is an issue that is more important than any individual career." I think he was talking about my career. "As painful as it may seem now, perhaps it may be less painful than could occur after publication." That almost sounds like a threat. I don't know. "I have learned to appreciate the value of silence, even in the case of superior data and information." He could not refute my arguments, and so he said, "Shut up anyway." I have learned to appreciate the value of silence. Now, this paper was formally published in a book by Professor Scott and Professor Griffin in August of, so there's several things happening, but anyway, August of 2006. In September 6th, I was put on administrative leave. I think this was probably part of it. And that was pretty much the end of my teaching career. Here I am teaching to a worldwide university, so thank you. Okay, thank you. NIST has found no evidence, this is quoting NIST, NIST has found no evidence of a blast or controlled demolition event. They made that statement, and then we wondered, because we're getting just a little bit skeptical, you see, we're thinking like scientists now. Wait, did they even look for explosives or explosive residues when they make this statement? Turns out they did not. So an investigative reporter, the reference is at the bottom, her name is Jennifer Abel, called up the NIST spokesman, his name is Newman. She asked, what about the letter where NIST said it didn't look for evidence of explosives? See, they didn't even look. They admitted that finally in a letter. Newman, who's listed as a spokesperson, right, because there was no evidence of that, huh? Shh, go away. Abel, Jennifer, but how can you know there's no evidence if you don't look for it first? Good girl, that's it. You know, investigative reporting, let's find the answer. Newman, if you're looking for something that isn't there, you're wasting your time. Now, am I missing something here?